Good day everyone. Welcome to the presentation on graphics, libraries, and frameworks.
Graphic libraries and frameworks are essential tools for creating and manipulating visual elements in various software applications. Graphical libraries are a collection of predefined functions, methods, and classes that provide developers with a set of tools to create and manipulate graphical elements in computer programs. These graphical elements can include things like shapes, image, animation, and even 3D models. These libraries serve as a bridge between software code and graphic hardware of a computer. They provide an abstraction layer allowing developers to work with a higher level of abstraction when it comes to creating graphics. One of the examples of the popular graphic library is OpenGL. It is an open source library that provides a wide range of functions and methods for rendering 2D and 3D graphics. It is platform independent, which means it can be used on various operating systems. DirectX is another well-known graphic library developed by Microsoft. Unlike OpenGL, DirectX is specially designed for Windows platform. It offers a comprehensive set of tools for creating higher performance multimedia applications, including support for graphics, sound, and input devices. Vulkan is more recent addition to graphics library landscape. It is a cross-platform library similar to OpenGL and offers low-level access to graphic hardware, allowing to developers to squeeze out of maximum performance from modern CPUs. This library provides underlying functionality for tasks such as drawing, rendering image, managing animation, and handling input from the user. By the using of predefined function and method, developers can save time and effort when creating visual appealing and interactive applications. In summary, graphic libraries are essential tools for developers look for to create and manipulate graphical elements in their software. They provide a range of predefined functions and methods to simplify the process and offer compatibility across different platforms and hardware configurations. Key features of graphic libraries. Graphic libraries offer a wide range of features including drawing, allows for creation of lines, curves, shape, and text. Rendering enables the display of image, texture, and 3D objects. Transformation provide the ability to scale, rotate, and translate graphical elements. Shading allows to realistic rendering through techniques such as lighting and shadowing. Advantage of graphic libraries. Faster development. Graphic libraries provide pre-built functions and methods that are specially designed to handle graphics-related tasks. These functions and methods are already optimized to perform and provide efficient algorithms for rendering graphics. By utilizing these pre-built components, developers can avoid reinventing the wheel and speed up the development process significantly. For example, instead of writing complex algorithms for rendering 3D objects or calculating shading, developers can simply call the appropriate function from graphics library. This not only save development time but also ensure consistent and reliable rendering across different hardware configurations. Cross-platform compatibility. Many graphic libraries are designed to be cross-platform, meaning they can work on multiple operating systems such as Windows, Mac OS, and Linux. This cross-platform compatibility allows developers to write code once and have it run on different platforms without the need for significant modification. By using a cross-platform, graphics library developed can reach a wider audience and ensure the application are accessible to users on different devices and operating systems. Extensibility. Graphic libraries often provide mechanisms for developers to extend their functionality. One common way is through the use of shaders, which is are small programs that run on the graphic hardware. By creating custom shaders, developers developers can implement special effects, lighting models, and visual enhancement. Additionally, graphic libraries may provide APIs or interface that allows developers to add their own features or customize the behavior of existing functions. This extensibility empowers developers to tailor the library to their specific needs and create unique visual experience in their application. Overall, graphic libraries offer numerous advantages including faster development through pre-built function, cross-platform compatibility for broader reach, and extensibility to add custom feature and effects. These benefits make graphic libraries essential tools to developers working with graphics-intensive applications or games.
Graphics frameworks versus libraries. Graphics libraries provide low-level access to graphical features, requiring developers to handle low-level tasks like memory management and event handling. Graphics frameworks, on the other hand, are higher-level abstraction built on top of graphics libraries. Frameworks simplify complex operations, provide an organized structure, and offer ready-to-use tools for developing graphical applications. Examples included Qt, WX and Xamarin.Forms. Graphics libraries are software components that provide low-level access to graphical features. They typically offer functions and tools to manipulate graphics and interact with hardware devices, such as graphics cards. Libraries like OpenGL and DirectX are example of graphics libraries. When using graphics libraries, developers have to handle low-level tasks such as memory management and event handling by writing code. On the other hand, graphics frameworks are higher-level abstraction built on the top of graphics library. They provide more comprehensive and organized structure for developing graphical application. Graphics frameworks such as Unity and Unreal Engine simplify complex operation of offering ready-to-use tools, functions, and features. Developers can leverage these tools to create graphics intensive applications without having to deal with the low-level details of the underlying library. Visualization of graphics libraries and frameworks. Visual representation comparing the role of graphics libraries and frameworks in the development process. Diagram illustrating the flow of function calls from developers to the libraries or frameworks and how they interact with the underlying hardware. Developer. Developer writes application code using programming languages like Python, JavaScript, or C++. They define the logic and algorithms required for their applications. Next is application code. Application code consists of numerous functions and methods that define the behavior of software. These functions are called within the application to perform specific tasks. Next is libraries or frameworks. Developers often utilize libraries or frameworks to simplify certain tasks or provide additional functionality. These libraries are or frameworks contain pre-written code and APIs that developers can use to perform common operations, such as handling networks, communication, interacting with databases, or implementing user interfaces. And next is operating system. Operating system acts that intermediary between the libraries and frameworks and hardware. It manages hardware resources such as CPU, memory, disk, and network, and provides an interface for the libraries frameworks to interact with them. And the last, hardware. The hardware layer consists of physical components like CPU, memory, storage devices, and network interfaces. It executes instructions and performs computations based on the request received from the operating system. Overall, the flow of function calls starts with the developer writing application code and making function calls to library or frameworks. These libraries or frameworks leverage the underlying operating system to interact with hardware resources efficiently and perform the desired task. Popular graphics libraries and frameworks. OpenGL, a cross-platform graphics library of rendering 2D and 3D graphics. DirectX, a collection of graphics libraries primarily used for Windows-based application and gaming. Vulkan, a low-level graphics library designed for high-performance application. Qt, a popular graphics framework used for developing user interfaces and graphical application. Unity, a game development framework with built-in graphics libraries and simplify rendering and assets management. Once again, I'm John Ashton D. Capareda.
My name is Aljun D. Sara.
Salamat sa inyong pakikinig at sana may natutunan kayo sa aming report. Yun lamang at maraming salamat. Paalam sa inyo.